Hi everybody, it's Ms. V. Hope you're having a good time at home, that you're staying safe, you're washing your hands, and welcome to your first week of online learning. I know it's been a crazy week or so, but we're going to try and keep ourselves grounded and go over a few things that you have either maybe forgotten or maybe were struggling with last time you were in class. And we're just going to touch base so that you're prepared for your check-in assignment, which is on Wednesday. It's not a test anymore, so hopefully you've read the email, right? It's not a test. Instead, it will be a check-in assignment, which will be available all day. If you need extra time, let me know. But we're going to go over this test review, certain parts of it today. It's still really important that we go over this. It's still some really important stuff, and it's definitely going to help to prepare you for next year. So today I want to go through a few things that some people were struggling with, okay? So on the very last couple of pages, it is that written response section. We are going to go through question number 7 and question number 9 on the next page. These are some pretty important things that I found people were struggling with, specifically how to write skeleton equations and how to fill in the products. This is something that was really important during assignment number 4. So if you haven't done assignment number 4 yet, make sure you're handing that in within this week because it is definitely late by now. But this will also help you out. Also might help you out with that assignment, okay? So what we're going to be doing here is writing out our skeleton equation. A skeleton equation is just those element symbols, right? Here we have our word equation, okay? WE for word equation, not we, okay? It says aqueous calcium chloride and aqueous sodium phosphate produce solid calcium phosphate and aqueous calcium chloride. Now that's a mouthful, right? If you're actually thinking about it, you'll understand it, but if you're just saying those words, you're like, hey, what do I mean, okay? So just remember aqueous, right? We heard that word multiple times. That just means that it's something mixed with water. Okay, it's something telling you about the state that it's in. Same with how solid is written before calcium phosphate. It's just telling you the state that it is in. And this is telling you the chemical compound. Okay, so very first thing you have to do when we're writing our skeleton equation is write down those chemical compounds in symbol form. Okay, so my symbol for calcium is Ca. And I know that my symbol for chloride, which is chlorine, is Cl. All right, there we go. Now this is where some of you may stop and say, okay, I'm good, let's move on to the next one. We gotta hold our horses right now. We are not finished yet, okay? So now that we've written down our symbols, your next step is to actually find the charges on this lovely thing you may remember as the periodic table of ions. Okay, so my charge for calcium is +2. So I'm going to go ahead and write that in pencil right here. +2. And my charge for chlorine is -1, right? Whenever there isn't a number there, we can assume it's a 1. Okay. So now that I have my charges, my last step is to crisscross them. So I'm going to take my 1, bring it down here. I'm going to take my 2 and cross it over to my chlorine. Okay. And now one other thing we have to remember is just a simple little rhyme. 1 is none. Okay. If there's a 1, I do not have to write it. So I can erase that there. Erase the numbers up top, and there we go. I'm going to write this in pen. This is our complete formula. So I know that in calcium chloride, I need 1 calcium calcium and I need 2 chlorines. Okay, that is a completed formula. Perfect. Okay, we also know that it's aqueous, so I'm going to go ahead and write that in brackets. AQ stands for aqueous in behind there. Okay, let's move on to our next one. Aqueous sodium phosphate. Okay, well I know that sodium symbol is Na. And now I have to find the symbol for phosphate. Now, one thing that you may have looked at is it doesn't end in "ide", it ends in "ate", and that is a very important clue. That is a clue that tells us this is a polyatomic ion. So instead of finding it in my table here, I'm going to find it actually up above in this table. Okay, so PO4, I believe that's what it is, right? Or phosphate, yes. If I look here, phosphate is PO4. Now the PO and the 4, those are linked together. In order to be phosphate, it has to have that little 4 in the end. I cannot change that. That is a very important thing. And I know that PO4 has a charge of -3. So let's go ahead and write that in. So PO4 is written together, has a charge of -3. And if I look back, sodium has a charge of +1. All right, so I've written down my symbols, I've found my charges, and now my third and final step is to crisscross them. So we go 3, goes to the bottom here, and 1 goes to the bottom here. Erase that, right? And 1 means none, so I can erase the 1. There we go. So I need 3 sodiums for every 1 phosphate molecule. Okay, and once again, that is aqueous. So we are going to write down the state in brackets behind it. And when these two mix together, you may have noticed already, if you're thinking about chemical reactions, this is a double displacement reaction because I have 2 compounds. So the only option is that it's going to make 2 compounds, right? And my metals here, my calcium and my sodium, are going to switch places, right? So when calcium comes over here, boop, I am now going to have calcium phosphate, which is exactly what is written right here, solid calcium phosphate. Awesome. I'm also then going to have sodium, come over here, boop, sodium chloride, which is written right here. Okay, so this is an example of a double displacement reaction. Okay, so I have calcium and phosphate. We already know what our symbols and charges are. Okay, so I know that calcium has a charge of +2. Phosphate has a charge of -3. So I'm going to cross that to the bottom. Cross this to the bottom. And erase my charges up above. All right, and so this is where some people will write that 4 and 2, and they'll be like, 2 times 4 is 8, awesome, I'll just write an 8 here. Now we want to make sure that we leave that 4 here. Remember what I said previously, the 4 has to be there, otherwise this is not phosphate. That's part of the equation, right? So what can kind of help is to separate these 2 numbers. I'll usually put a bracket in. There we go. So for every 3 calcium, I need 2 phosphate. All right, and I know that this is a solid, so I'm going to go ahead and put a little S in behind. Also makes aqueous sodium chloride. So sodium is Na, chloride or chlorine is Cl. And I already know that sodium has a charge of +1 and chlorine has a charge of -1. So when I cross these, Okay. They both have a 1 and a 1. I can simply erase everything. I don't need to write any numbers below this one. Awesome. I just need to remember that my state is aqueous. And there we are. We now have our finished skeleton equation. Awesome. Our last step with this is to now balance it. Okay, so for this step, I'm going to do this in pencil. Pencil is always a good idea when you're balancing equations because there's lots of erasing. So first I'm going to go ahead and draw a line down our middle. So now it's reactants versus our products. And just account for what elements I have on each side. Calcium, chlorine, sodium, and phosphate. Since the PO4 stays together on both sides, I can just account for it that way instead of breaking it into phosphorus and oxygen. Right, save me some time. There we go. So I have 1 calcium. I have 2 chlorines, 3 sodium, and 1 phosphorus. I have 3 calcium on this side. I have 2 phosphorus molecules. I have 1 sodium and 1 calcium. Awesome. So let's go ahead and balance our calcium first. So I have 3 on this side, and I only have 1 on this side. Now I can't add little numbers in here, right? I can't just make it a little 3. Ha! It's cheating. It's too easy, right? I need to make sure that this formula stays the same. Otherwise, that is not calcium chloride anymore. But what I can do is add big coefficients to the front. Okay? So if I only have 1, but I can multiply it, well, 1 times 3 equals 3. So if I multiply this side by 3, it's going to multiply into here. 3 times the 1 calcium. I now have 3 calcium molecules. However, this also multiplies into my second element as well in the compound. So now 3 times 2 is 6. I now have 6 chlorine. There we go. So now that my calciums are balanced on both sides, I need to make sure that my chlorines are. I have 6 on this side and only 1 on this side. So I can look, here's my calcium, right? What times 1 equals 6? Well, 6. If I multiply this entire compound by 6, I now have 6 times 1 is 6 sodiums. And 6 times 1 chlorine is 6 chlorines. Well, now my chlorines are balanced. Now my next step is to move on to my sodium. I have 6 sodium over here and only 3 on this side. Right? I can see that little 3 down here. So I have to make sure that whatever I multiply this 3 by is going to give me 6. Okay, so 3 times 2 equals 6. There we go. Now my 6 and my 6 are equal, but I cannot forget that this 2 has to go to the other elements in my compound as well. Okay, so now I also have 2 phosphate molecules, which, by good luck, makes this side balance out as well. So now I have the same amount of each element on either side. It is now following the law of conservation of mass, and it is perfectly balanced. Okay? So hopefully this is what you had. If not, you can now go and rework it. Okay, I'm also just going to go over one example on the next page. Okay, So this is something that some of you were struggling with in assignment number 4. It would give you the beginning of your chemical reaction, and then you had to fill in the rest. You had to figure out what was made from that reaction. So this is where you had to know what type of reaction it was. You have 5 different options. It can be synthesis, where usually 2 things come together to make 1. It could be decomposition, where 1 thing breaks down to make 2 things. Okay. It could be single displacement, where you have a single element, okay, that's why it's a little tiny line, plus a compound, okay, so that's 2 things put together, and it's going to give you a new single element and a new compound. Double displacement, okay, where, you're going to have a compound plus a compound, and they're going to give you 2 new compounds. And combustion. You're usually going to have some type of element plus oxygen, or compound, and oxygen, and it's always going to give you carbon dioxide and water. Okay, so those are our 5 options. When you look at A, right, you should notice right away that it is a single element plus a compound. You have SN plus silver nitrate, okay, and that is now going to give you a new single element and a new compound. Okay, so imagine this as our dancing couple at the prom. Okay, this is the person sitting on the sidelines, and they're going to come and cut in on that dancing couple. They're always going to cut in on the same thing as them, right? So my SN, that's tin, right? That is a metal, so it's going to cut in on the other metal in this compound, which is silver. Okay, so once the SN, the tin, comes in and cuts out my silver, I'm left with a new compound. I'm left with tin nitrates. So I'm going to go in and write in my compounds. Okay. What's going to be my new lonely element? Well, the one that got kicked out. It's going to be my silver. Okay. And this is where some of you made a mistake. You now wrote down your elements. You might, okay, I'm done, perfect. But really, like we know now, that is only step 1. Okay, step 2 is, for my formula, I need to find my charges. Okay, so let's go ahead and find my charges for tin. Tin's a little bit tricky. Okay, when I'm looking, I notice that there's 2 options. Okay, whenever it doesn't tell you, right, it doesn't tell us what charge tin has. So we're just going to pick the top one because that is the most common. That is your safest guess. So we're going to pick tin 4. Okay, so I'm going to say that tin has a charge of positive 4. I'm also going to look at NO3, which is nitrate. Okay, and it has a charge of negative 1. Okay. So now when I crisscross those, the 1 gets brought to the bottom of my tin, the 4 gets brought to the bottom of my nitrate. Okay, so I'm going to go ahead and erase this. Right, we can erase the 1. I'm going to draw a bracket to separate the 4 and the 3. So I know that for every 1 tin, I need 4 nitrates. Okay. I also need to look at my single element. As long as it is not part of Hofbrinkel, I can leave it alone. Right? This is not part of Hofbrinkel, so I don't have to worry about it. However, if it was, I have to remember to write a 2 at the bottom. because that means that it is more stable when it is paired together. So if you ever see a single H, you know you always have to write a 2 behind it. All right? So I hope that helps you out. Go ahead and try B and C on your own. I am going to post the answer key probably tomorrow for this to help you out. I'm also going to be making another video tomorrow, but I want your say on what we go through. So please make sure you go through this review booklet and circle any questions that you're having a really hard time with, and I'll make sure to include those in the video tomorrow so that you know how to do them properly. All right, I hope you guys are having a great day and that your other classes are going well. Take care, wash your hands, and I hope to see you soon. Have a good day, guys. Bye.